Hi, everyone. My name is Asim Sasmal. I'm a senior data architect with AWS Professional Services, helping our IoT customers to build industrial data solutions with AWS IoT. Today, in this webinar session, I'm going to walk you through pretty much everything you need to know regarding how to build an end-to-end industrial IoT solution with AWS IoT. To start with, I'm going to walk you through the common industrial data challenges we learned from our customers. Then I'm going to go through what is needed in an end-to-end industrial data solutions. I'm going to give you a quick overview of AWS IoT Analytics services for IIoT solutions. And then I'm going to take you through a step-by-step customer solution walkthrough covering common customer asks and core design considerations, an end-to-end solution architecture, and then also a demonstration. I'm going to then leave you with where do I go from here, and then we will wrap up with question and answers. All right, let's get started. At AWS, our customer engagements usually start with a simple question. If you knew the state of everything and you could reason on top of that data, what problems would you solve? And then the question we always get from our industrial customers is, how can I leverage my untapped industrial data? Basically, to take it to cloud for unbounded analytics to optimize my operations. Let's take a look at the pain points for industrial data. Industrial data has gravity, but industrial data is untapped. What you really want to do is democratize access to the data for your industrial analysts to explore and find insights which are either never seen before or was extremely difficult to get. Data is undiscovered into on-premises historians in silos and hence makes it difficult to analyze without going through a complicated extract and copy process to be able to use your tool of choice. What you really want to do is build a consistent and open data store for all your data with flexible ingestion tools and make it easily accessible. Pretty much every customer we go to want to use artificial intelligence and machine learning, but they're very early in their journey. What you really want to do is use future-proof managed machine learning tools to reduce the undifferentiated heavy lifting from your teams and go faster from descriptive to preventive to predictive analytics. So to solve all that pain points, you are really looking for an industrial data solution with ability to collect and store any data at any scale in a very cost-effective way. This not only includes your data from your on-premises historians and SCADA systems, but also includes enterprise data such as ERP systems, third-party data like weather data. Basically, you want to bring all of your data together in one secure home and hence avoid any type of data silos. Once all of your data is in one home, such as in an industrial data lake on AWS, we often refer to, you now have the choice to use the right tool for the right job. You also have multiple internal and external applications, most of which are on premises, which you have built years ago. You can expose RESTful APIs in the matter of minutes to access your data from the cloud from anywhere securely. But IoT solutions are multidimensional and complex to implement. AWS IoT services help you to manage that complexity. While building an IoT solution, usually there are three questions come to mind. How can I connect my devices and operate at the edge? And that's device services. How can I control, manage, and secure my devices? And that's control services. And then how do I extract value from my data? And that's AWS IoT Analytics services. Let's get a quick introduction of the relevant AWS IoT Analytics services for IIoT solutions. AWS IoT SiteWise. AWS IoT SiteWise is a fully managed public preview service that you can use to collect, organize, and analyze data from industrial equipment at scale. The service enables you to collect data on the plant floor from sensors, equipment, or a local on premises gateway and upload to AWS Cloud using a gateway software named as AWS IoT SiteWise Connector. The connector runs on common industrial gateway devices running AWS IoT Greengrass and reads data directly from servers and historians over the OPC UA protocol. You can also ingest data directly into AWS IoT SiteWise, either via MQTT or using Batch Put API. You can structure and organize the data from your assets using a rich asset modeling framework to create virtual representations of your equipments and processes from your sites. The data ingested and modeled in IoT SiteWise is stored in a scalable and time-optimized internal data store. Once the data is stored in AWS IoT SiteWise, you can stream live data in near real time and query the historical data to build downstream IoT applications. With the recently announced SiteWise Monitor capability, you can explore your library of assets and create and share operational dashboards with plant operators for real-time monitoring and visualization of equipment health and output. AWS IoT Analytics. AWS IoT Analytics is a fully managed AWS IoT service that allows you to filter, transform, and enrich IoT data for analysis without having to worry about cost and complexity typically required to build an IoT analytics data processing pipeline, starting from scratch, as well as including orchestration and scheduling. AWS IoT Analytics is backed by Amazon S3 as the storage. So what that means is you can have your own managed S3 buckets in your data lake, which means your data is already in a central and secure data store. Like you have seen with other AWS services, AWS IoT Analytics provides out-of-the-box seamless integration with Amazon SageMaker, Jupyter Notebooks for machine learning by your data scientists, and then Amazon QuickSight for BI reporting, and an IoT Events for complex conditions monitoring. You can also use your own custom analysis or your code. Let's say if you have a Python code, you can package that in a container and to execute that out of AWS IoT Analytics in a scheduled way. AWS IoT Events. Think of AWS IoT Events as a conditions monitoring service. It is a managed service designed to detect state changes and trigger actions. The service is stateful with built-in state management at scale. The service monitors multiple sensors and applications simultaneously to detect critical events, both idempotent and strictly consistent. The service manages the state of devices and processes, and more importantly, it's instantly scalable. You don't have to do any heavy lifting with it. And then the service also has a library of pre-built responses, support for inbuilt support for IoT Core, Amazon SNS for notifications and alerts, AWS Lambda to run your custom functions, and then Kinesis Firehose for streaming data to any other destination or any other AWS services. Let's dive deep into a real customer solution walkthrough. If we sum up everything, what our customers ask in the industrial space is that the solution should be scalable and cost effective by using fully managed, auto-scalable, serverless, transient, pay-per-use AWS services wherever possible. Just like how security is job zero at AWS, our customers in industrial space are extremely cautious about security, and they should be. They want to enforce encryption at rest and in transit for all of their data from field to cloud using either AWS managed or their own encryption keys. With Amazon SageMaker, customers want to put machine learning in the hands of every developer and data scientist with undifferentiated heavy lifting managed by AWS to find out ways to optimize their operations. With streaming data, customers always need a near real time operational metrics visualized on a dashboard and then send notifications and alerts for actions for operations team as necessary. Customers have internal and external apps on premises. So they want to build APIs using fully managed and hosted API gateway. In addition to that, they're also looking for simple SQL access for their data scientists and data engineers. And last but not the least, customers want to build business intelligence dashboards and emission reports for regulatory bodies such as EPA agency in oil and gas space. Hence, they're looking for a completely managed BI tool without a client server model to manage for their teams. Now, after hearing all the requirements, if you start to categorize your requirements into technical outcomes, there are usually 6 things. You are looking for setting up field to cloud connectivity, going through your infosec requirements, your which ports you can open, which ports you cannot open, and things like that. And then once you have figured out the connectivity, you are talking about collecting the data, organizing the data, processing the data, and storing the data. And then you are also looking to monitor operational metrics in near real time. You are looking to do alerting when certain thresholds are breached. You're looking to build a central data store for historical data analysis, often known as industrial data lake. And then you're looking for running business intelligence reports out of the data you have stored. Let's walk through the architecture step by step. This is the core architecture of our usual industrial customer solutions we see with. The left side of it, which is the customer on premises, usually it differs depending on your infosec setup, your security on premises. However, they're more or less similar. So you have your PLC. From your PLC, there is usually a protocol converter, which is something like KEP server EX in this walkthrough. However, there are quite a few other partners who play a big role there, so you can choose, it's your choice. But in this walkthrough, it is KEP server EX from KEPware, which helps to take the PLC protocol, which can be one of many, to a standard protocol named OPC UA. Once your data is available in OPC UA protocol, you have AWS IoT Greengrass and Sitewise collector or connector software running on the edge gateway, the hardware device. It's usually, there are multiple choices for you to choose from. In this walkthrough, you see that customers are using OnLogic, Moxa, Advantech, depending on again your vendor of choice, and depending on if the architecture is supported and certified with AWS IoT Greengrass and Sitewise connector. Once the data is collected by AWS IoT Greengrass and Sitewise connector, the data is sent to the cloud, to the AWS IoT Sitewise data store. And we refer to this data store as operational data store. Think of this like your hot data, the data where you need very low latency support. And then once your data is in IoT Sitewise, you obviously can create AWS, you do basically asset modeling within Sitewise. And basically you create virtual assets or virtual representations of your assets and processes in there. Once your data is in Sitewise, Sitewise provides an out-of-the-box managed web application for you to monitor the asset hierarchy you have created using your asset model. And that's used by usually your personas like operators, managers, analysts who are monitoring your operations on the floor. And then once the data lands to Sitewise, Sitewise also gives an option to take the data out of Sitewise for building other IoT applications downstream. The way you do it is within Sitewise, you basically choose an option. It's at the click of a button saying that I want my data to be available from Sitewise in a message broker in AWS IoT service, AWS IoT Core Rules Engine. Once your data is in AWS IoT Core Rules Engine, as you learned before with AWS IoT Analytics capabilities, we send the data through AWS IoT Analytics to flatten the data, to transform the data a little bit, to make it easier for downstream consumption. And then once your data is in IoT Analytics, AWS IoT Analytics has a scheduled job, which is think of this like a SQL query, which is basically saying that I would like this data to be aggregated to some extent, and I would like that metrics to be monitored by AWS IoT Events to look for rules or conditions when I should be sending an alert or notification to someone on the factory floor. And basically, you set up a data set in IoT Analytics, and that data set triggers AWS IoT Events rule. And then within AWS IoT Events, you monitor it, and then you send an alert when the condition is met. And then if you remember, AWS IoT Analytics provides out of the box Amazon SageMaker integration for notebooks for your data scientists and data engineers to look at the data and run machine learning models. And then we also talked about AWS IoT Analytics is backed by Amazon S3 in your own AWS account. So by the virtue of data landing in AWS IoT Analytics, you have your data sitting in your industrial data lake, which is usually known as an warm or cold data. Think of this like your historical data store for all of your history you want to keep there and analyze. Once your data is in data lake, using AWS Glue crawler, you can schedule a crawler which can crawl this data in every 5 minutes, 15 minutes, depending on your frequency. It collects all the metadata and pushes it to AWS Glue data catalog. Once your AWS Glue data catalog is updated, you can query the data using plain SQL or simple SQL using Amazon Athena, which is one of our analytics services. And then obviously, if your data scientist wanted to get hold of some other data sitting in your data lake, not just IoT data, they can always use Amazon Athena from the same notebook they're working on from IoT Analytics to pull some data from the data lake. And then finally, you got a BI reporting and self-serve analysis for your historical data for your regulatory agencies. When you need to dive deep into data and look at some trending and historical data, you will be using Amazon QuickSight. And QuickSight has an out-of-the-box integration with Amazon Athena so that you can query the same data from QuickSight. All right, let's move on to demonstration. So in this particular demonstration, the architecture I walked you through, it's basically trying to demonstrate a wind farm where you have 3 wind turbine units. Each wind turbine unit has 2 PLC units. There is an unit 1 PLC, there is an unit 2 PLC, and you will see that in all 3 of them. If I go to unit 1 PLC, there are 3 tags. One is for generated power, the other one is rotor speed and wind speed, and then unit 2 PLC has equipment temperature and outside temperature. This is basically a simulation of data using Kep Server EX simulation driver. But again, in reality, if you have a different OPC UA server and you want to use a different simulation process, you're happy to do that. This is basically for the demonstration purpose. So now that you saw the tag setup and the simulation driver, going to simulate the data for this. Um, if you click on something called Quick Client for KEP server, in the Quick Client, this is provided out of the box from KEP server. You should be able to see whether your data is being simulated or not. And as you can see, the data is being simulated, the values are changing. Now let's get back to the AWS console. Now, in AWS console, I'm in AWS IoT SiteWise. Now within SiteWise, you have a component named Gateway. You have build, under build, you have models and assets. Remember I mentioned about asset modeling, where you basically model your virtual assets and properties from your industrial sites in the cloud. And that's how you add basically, metadata to your data, which is streaming from the field. You basically contextualize your data, right? So let's look at the asset model tree first. Basically, one of the things you should do before you ingest data to Sitewise, we recommend that you build an asset model first, because if you don't, then your data will not be stored by Sitewise; it will just be ignored. So the first thing you should do is you should create an asset model. In this case, like I showed you in the KEP server tags, this is a wind farm and it has 3 turbines. So wind turbine 1, I have basically 2 assets, wind turbine 1, PLC unit 1, and PLC unit 2. Let's look at PLC unit 2. In the PLC unit 2 asset, I basically have a bunch of attributes. In this case, I have 2. I say what's the model number, what's the name of it. And then you see under measurements, I have outside temperature and equipment temperature. You saw the tags I showed you on KEP server EX, and this is the path for the KEP server EX tag, which is from the root node, which is wind turbine 1 unit to PLC and outside temperature. This is really where you associate the KEP server EX or OPC UA tag with the measurement, and we call that alias. And then there is metrics. Think of metrics are like KPIs. You want to key performance index. You want to compute at a particular frequency. In this case, I'm computing average equipment temperature and average outside temperature in every 5 minutes. And then remember I mentioned that whatever data lands to Sitewise, you can send it to AWS IoT Core Rules Engine message broker by clicking a button. And that button is really turning on notification status set to enable. What this means is this data is already available in IoT Core Rules Engine message broker for downstream applications which are outside Sitewise can consume this data and keep building. Now, going back to from assets, I'm basically working backwards a bit here. So the first thing you do is you create a model and then you create an asset. I showed you the asset because the tree kind of gives you a feeling in terms of visual how your asset tree is going to look like when you build it. But think of models more like a template. You have hundreds of sensors. You want to create one model for that sensor. If all of the sensors are from the same manufacturer, are basically the same model template. And then once you have created a template or a model template, you then can create hundreds of assets out of that model. So in this case, I have a model for Unit 1 PLC. And as you can see, I have model name as the static attributes. I have measurement information, wind speed, rotor speed, generated power. I am not doing any transformations. Think of transformation like taking your data and massaging with it row by row on the fly. As an example, from the field, you might be getting temperature in Celsius and you want to convert it to Fahrenheit. So you can apply your formula in the transformation and it will take care of it. Metric definition, like I mentioned, think of it like aggregated KPIs, like a 5 minutes average in this case for wind speed as well as max generated power. Once you have defined the model, once you create the assets, your assets show up at the end like this, right? But bottom line is you start creating models. Think of them like templates. Then you instantiate your models to create your assets, and then you create basically the asset tree I showed you for the wind farm in this case, which is the wind farm at the root of your asset tree, and then you got 3 wind turbines, and then each wind turbine has 2 PLC units. All right. Now we discussed about asset tree. Now remember, Sitewise needs to know where to collect the data from, and the way it does it is it has a component called Sitewise Gateway. Think of this like a logical um, edge gateway, not necessarily physical, because your physical device is actually running AWS IoT Greengrass and AWS IoT Sitewise connector to pull the data from on premises. So the communication they do with cloud using a gateway, which is known as Sitewise Gateway. When you go to Sitewise Gateway, you have something called source configuration. This is where you basically mentioned your OPC UA endpoint. And in this case, this is the IP address and the port number for your CAP server EX OPC UA server. You saw it. And at the same time, when you add a source, security is job 0. So you do have option to choose a couple of security options from. In this case, I've chosen basic 128 RSA 15, sign and encrypt. What that means is CAP server also supports this, which is why I've chosen this. And when Sitewise communicates with CAP server via AWS IoT Greengrass and Sitewise Collector software, it basically does a handshake using this security policy. And you need to go to CAP server and trust the certificate before the data can stream to the cloud. And then lastly, you got OPC UA nodes, and you see that I mentioned wind turbine 1, 2, and 3. These are basically saying that from that particular OPC UA server, I only care about the tags which are under this nodes. And that's basically how you can filter out unnecessary tags to come to cloud and store. Okay, so far you have done asset modeling in Sitewise. Basically, you've created virtual assets of, from your field or sites. You have created a gateway saying pull the data from this CAP server EX. And then the last thing you have in Sitewise is you can monitor the operational metrics dashboards for that asset tree you just saw in near real time. How do you do that? So within Monitor, there is something called portals. And then when you go to portal, think of portal like a, Sitewise Monitor is basically an hosted and managed web application provided by Sitewise out of the box, right? So you got an URL to access to it. So you the first thing you do is you basically set up a portal. Basically, you create a URL, and I've created that already in this case. Once you create the portal, in the portal, you can add portal administrator, you can add portal users, and then if you click on that URL, you will be taken to the Sitewise Monitor web application. Now, one thing you should know is that Sitewise Monitor currently is authenticated and authorized by AWS SSO. That's the supported way to provide access to your end users. So if you want to give access to your end users to this portal onto certain dashboards, you need to create their user IDs in AWS SSO and share it with them. Now, in my case, the first thing once you are in the portal, what you do is you basically create a project. I have a project named Monitor Wind Farm. Once you create a project, within the project, you basically create your dashboards, your operational metrics dashboards. And then, you obviously associate some assets to your project. In this case, whatever asset model you have created or asset tree you created, it automatically shows up here under wind farm. You really don't have to do anything to bring them here. You just have to associate it to a project you are going to create dashboards for. In this case, now let's go to a dashboard. I have 2 dashboards, one for wind turbine 1, unit 1, and another called wind turbine 1, unit 2. Let's go to wind turbine 1, unit 1. In this particular dashboard, as you can see, this is basically a near real-time dashboard. It's monitoring live It's set to last 10 minutes view. You can go from last minute all the way up to 90 days of history, or the data sitting in SiteWise. You should be able to visualize it anytime. So in this case, this particular demo has been running for a while. So I can change the range to maybe last 7 days, things like that. As you can see, there isn't really a lot of variation because it's simulated data. But here is how you want to modify it if you want to. When you click on edit, on the right side, your asset tree shows up. Under your asset tree, you have wind turbine 1, wind turbine 2, and wind turbine 3. And in this particular one, I have chosen wind turbine 1. And under wind turbine 1, when you go in, you basically have generated power, wind speed, average wind speed, max generated power, and rotor speed. So if you remember, wind speed, generated power, rotor speed, they are basically your raw data coming from the field. Max generated power and average wind speed are your average 5 minutes and max 5 minutes average. So, and all you do from here is you basically drag and drop. Let's say you want to do wind speed and generated power overlaid on each other. So all you do is you drag and drop it. You can choose different chart types. Currently, SiteWise supports a line chart, a bar chart, and some KPI mode. If you wanted, you can switch it to a KPI mode as well. If you want bar chart, you can do that. And then after that, you just save it and it's live for you. You can put it usually on a factory floor for your operators. This is again a near real-time dashboard, which is always showing you the latest status. All right. So now we looked at in SiteWise, we ingested the data, we did asset modeling, we looked at near real-time operational metrics dashboard. And remember, I said that your data is also going to the message broker in IoT Core Rules Engine, and you can consume your data from there to wherever you want to send it. In this case, in the architecture I showed you, I want to send the data to AWS IoT Analytics. So let's go to IoT Core. All right. So I am in IoT Core, and I have a rule named Sitewise WinFarm demo rule for IoT-A. IoT-A stands for IoT Analytics in this case. If you see, I have a rule specified, and I have said from the reserved topic, which is AWS SiteWise asset models, send all the data which is being sent to IoT Analytics. And in IoT Analytics, I have a channel. Think of channel like a raw input data store for IoT Analytics. So it's basically sending the data to IoT Analytics. Let's go to IoT Analytics. In IoT Analytics, you got 4 different things to really know about. Channels, which is where your raw data lands, and you just saw that IoT Core is sending the data to this channel. So if you go to channel, again, this is backed by an S3 bucket. You see that I have an S3 bucket named Sitewise WinFarm Demo IoT channel. That's where the data is really landing. And as you can see, my data is flowing. It was showing me the last 12 hours, last 1 week, things like that. If for some reason data flow stops, you won't see this graph moving at all. So your data is landing to IoT Analytics channel. Once your data lands to IoT Analytics channel, you got something called a pipeline. So in the pipeline, think of the pipeline more like an ETL extract, transform, and load pipeline for your streaming data. I have a pipeline. All it does is it takes the data from IoT Analytics channel, which is the input, and then I have something called activity. And you can choose multiple activities from the list. Think of this like your data is coming from source as type. There is a payload. Within a payload, you have asset ID, property ID, and then you have values, which is an array. The reason I want to simplify this structure for the downstream end users, because querying array is usually not a fun. So hence you would like to simplify this. The way you do it is you add something called an activity. In this case, I have an activity called Lambda. And in the Lambda, you can see that it's pointing to one of my Lambda functions named Sitewise Demo Transform functions. All that Lambda function does is it takes 10 messages at a time, and you can go up to 1,000 messages here. Because keep in mind, again, IoT data is high velocity data, and you really don't want to trigger one Lambda per message. You want to batch it up at least near real time and then trigger one Lambda per, let's say, 10 messages in this case. So I have done 10 for this demo based on the velocity I have. Now, let me just show you what the Lambda does. So you saw the data which comes as an array out of Sitewise, but I need to make it a little easier for end user query downstream. So all I do is I have a simple Lambda which reads that payload above and flattens it out to something as simple as this. So that it's ready to be queried by, let's say, Athena downstream as one of the user personas usually customers ask for. So all that Lambda is doing is taking a payload, flattening it out, and pushing it to something called a data store. And again, this particular data store, think of that like your target for the pipeline. And in that target, you basically, again, backed by an S3 bucket. And in the S3 bucket, you have your data going into an object prefix named Sitewise WinFarm Demo Silver. Once your data lands there, you are ready to query this data and consume it. There are two ways I'm consuming it. If you kind of think of the solution architecture I showed you earlier, there is a data set which is being created for IoT events or to feed it to IoT events. So in IoT Analytics, you can create a data set either via SQL. Let me quickly show you how. So you can either do a SQL data set or you can create a container. Think of container like you have a custom code, you have a Python code or some kind of a code which is something you want to run on your streaming data as input, and then you want to get an output, and then you want to send that output for something, right? So you can put your custom code in a container, and then you can basically schedule this container to consume the data from IoT Analytics and run your processing logic. In this case, however, I am creating just a SQL data set. So in my case, I have a SQL data set. I have a SQL query. The query is little bit difficult to see it on the screen. However, all that query is doing, if you look at it, it's pulling the last 5 minutes worth of history or streaming data, and then it's looking for three different tags. Basically, it's looking for one tag, which is equipment temperature for all the three turbines. And it's coming up with an average value for last 5 minutes, and it's 84. And this data set, this output is fed into IoT events for conditions monitoring. And within IoT events, this data is being monitored by a detector model. Think of detector model like where you define your complex industrial data events aggregation rule, when to send alerts and notifications, for when certain thresholds are crossed. So in this case, those three records you saw from IoT Analytics from a scheduled job, which is running in every 5 minutes. Think of this more like a cron job. So IoT Analytics out of the box lets you schedule this job. The job sends you three records. Those three records go here in the detector model. Once it comes here, it says, well, let's check whether I am good or in critical state. If the temperature goes beyond like a critical counter of 2, then it switches the states to critical. But before that, how do you update that counter? So what you do is within the good state of the detector model, you basically define when to increment the counter. So you are checking for a temperature value greater than 70. If it's greater than 70, then you are basically saying that I want to set a variable, and the variable is incremented and it's called critical counter. And that's the critical counter you check in the transition phase. If it is greater than 2, you go to critical. Now, let's say the job runs in IoT Analytics, it continues to run. Next time the temperature comes out to be 69 degrees Fahrenheit, in which case the critical state will be reverted back to good state. And under good, it checks for the counter down to 1 or less, as simple as that, right? But what happens when you switch to critical? You basically send an alert. And remember, like I said, you use SNS to send a particular alert. This is the SNS topic where it's configured for an email. So basically, it sends an email saying, "Hey, the temperature for the last 5 minutes or last 15 minutes, it's going upwards, and you should have someone take a look at it." Okay, so that covers the alerting piece of it. Now, if you remember, the data is already in S3 bucket. So let's go and take a look at that. And in S3 buckets, there are really two buckets. One is the data lake raw, and then one is the data lake IoT analytics data store. These are the two buckets you saw. So my data is literally here. And then once my data is here, I should be able to query it from QuickSight or Athena. So I'm going to QuickSight now to show you how I can access this same data sitting on S3 bucket by an IoT analytics data set. In IoT analytics, there was a second data set I haven't touched on yet. So if you look at the second data set, which is basically a Sitewise wind farm demo data set 2, it's again a SQL query. And the query is pulling data for last 6 hours. All it's doing is it's sending and it's creating that data set, which looks like this, and keeping it. And then from QuickSight, you basically create a QuickSight data set, and then you access that same data from IoT Analytics to visualize. How do you do that? You basically create a data set, name, in this case, Sitewise Wind Farm Dataset 2. As you can see, it has received 39 million records. It's about 7.2 gigabyte data set. And then this particular data set, you should be able to visualize it. I already have an analysis I was running on. So all you do at that point is you go to QuickSight. That data set is what we just looked at. And I am basically plotting and in particular, timestamp the temperature, equipment temperature against the timestamp here. So again, you got your data ingested in Sitewise, you did an asset modeling, you sent it to the Sitewise monitor, and then from there, again, you send the data to IoT Analytics for some kind of a messaging or processing before it's consumption ready. From IoT Analytics, you send your data to QuickSight for visualization, out of the box integration, and then you also send the data to IoT Events for alerts and notifications. Okay, there is one thing, in case you are wondering, when should I use Sitewise Monitor as a visualization tool versus Amazon QuickSight as a visualization tool as well. The way I would differentiate them is think of AWS IoT Sitewise Monitor is for near real-time operational metrics, runtime charts, um, basically something which is always moving and tracking your status. Then and there, it's always there on your factory floor. Your operators are looking at it. Whereas QuickSight, think of it more like a batch analytic tool where you can do your business intelligence reporting. You have canned reports to produce from historical data of, let's say, last 5 years, last 2 years. You want to look at the data sliced and diced in a different way. That's really a traditional BI tool function QuickSight serves. I hope that helps. Let's go back to our presentation. So one of the common questions we always get from customers is that, well, you showed me how to do the streaming data, how to build the history and things like that, but how about all my historical data and my legacy applications which are sitting on premises? What do I do with that? So The usual recommendation or a pattern is that whatever data you have in your historians on premises or enterprise data assets such as ERP, CRM systems, you get those data into cloud, into the data lake, into the same place where your IoT analytics data was stored. And you can use AWS tools like AWS Snowball for really large volume of data, especially let's say if you have multiple industrial sites, you need to bring terabytes of data in your first cloud migration. So you'll be using a tool like Snowball. And then AWS DMS is more for a database replication software. So if you have a lot of on-premises databases, which you cannot necessarily just remove them and move to cloud, all you'll do is you will set up a replication job using AWS DMS service, and it will bring the data to the data. And then same thing for your legacy applications like .NET applications, and we see a lot with our industrial customers, or Java applications, which were built really quite some time back, and all of them need to continue to access data. The difference is that data is in the cloud now. So all you do is you basically create some RESTful API using Amazon API Gateway, really in the matter of minutes. And basically, those are the APIs which these applications will be using to access the data from the cloud. Now, having said that, um, where do you go from here, or where could you go from here? Um, AWS IoT SiteWise is a public preview service, so you're free to try it out. In fact, the interesting thing is that you do not have to pay anything for the service while it is in preview. So please go ahead and try it out. You don't need a whitelisting for that. And then there was recently announcements at reInvent 2019. What's new with AWS IoT Analytics services. You will see that there are quite a few pretty interesting features announced, um, some of which I've gone through in my demonstrations. And then last but not the least, you want to try it out, go ahead and look it up. There is a 3-part step-by-step blog post which will take you through this entire demonstration I showed you, starting from simulating data to ingesting to cloud, all the way up to your BI reporting and other outcomes you would like to try it out. With that, thank you so much. We are ready for question and answers.